Okay, this is chapter 1.2, the core concepts for your notes. These are just all parent functions. These are the parent functions that we're going to be dealing with in this section. I mean, there's more that we're going to be dealing with throughout the year, but for this section, this chapter, this is what we got. So we've got 4, and we'll do these one at a time. A constant function would be something like f of x, which we're talking about functions, we're going to use function notation. Remember, we just use f of x is the same thing as saying, is equivalent to saying y. Okay? It's the same idea. So just go with it. But it's considered function notation. But f of x in this case equals a certain number, 1. All right? There's really only one variable. X equals 1, or y equals 1. But the parent function is f of x equals 1. And so if I were to graph this, now I'd like you to use a straight edge to graph these, okay? And the reason being is I want you to be nice and neat. Now I cannot do this on my iPad, but, so f of x equals 1, this is your y-axis, this is your x-axis, and this is the point 1 right here. You will get a straight line that is horizontal. And that's the parent function for x equals 1. For y equals 1, or f of x equals 1. Okay? That is a constant function. Now the domain, remember domain is x values. Pardon me. Domain is x values and range is y values. X values. Range is y values. Now the domain for this, it goes left forever. Yeah. Goes left forever and it goes right forever. So, and with everything in between, and what we call that is we call that all real numbers. Okay, so your domain is all, wow, that does not want to work, all real numbers. And another way of notating that is, remember that whole R with the double back? That will be all real numbers. Okay? The range of this, range is your y values. Well, there's really only one value in it altogether. So your range, in this case, is y equals 1. It is only at one point. It's not at 1.001, it's not at 2, it's not at 3, it's only at y equals 1. That is the only y value being used. Okay? Linear you dealt with extensively in Algebra 1, but that would be, remember, f of x equals just x. Remember, that's the whole y equals mx plus b. That is a linear function, but this is the parent function. That is the most basic form that is still a linear. And if I draw my x and y axis, y, x, the parent function goes straight through at a 45-degree angle. Oop, wrong color. Straight through at a 45 angle. Oop. Computer dropped it right like that. Alright. And nice 45-degree. But that's the parent function. Now we can shift it up, we can shift it down, we can move it left, right, all that sort of stuff. Alright. The domain and range, okay? The domain, it goes left forever. Alright? And it goes right forever with everything in between, so we're going to call that all real numbers. Alright? Same with the range. The range is your y values. It goes down forever and it goes up forever. So again, we're going to call that all real numbers. So the domain and range for a linear function is all real numbers, especially the parent function. Okay? Absolute value. Now we showed you the absolute value in your vocab. You haven't gone over the vocab yet. You probably should. But your absolute value function is f of x. F of x equals the absolute value of x. And that's what those bars mean. They mean absolute value. So if I were to graph it, okay, there's my x and y. It is just like a linear in many ways, so it goes up at 45 degrees. But remember, everything negative, it creates positive. So what it does is when it hits 0, 0, it turns around and goes up like a linear function, but in the other direction. All right? And that's what it looks like. It looks big V. I always remember this by thinking absolute value. That's the V function. All right, domain. Domain is x values. It goes left forever and it goes right forever. So it's all real numbers. Range, however, it does not go down forever. It starts at 0 and it starts right here at 0 and goes up forever. So, two ways of notating that. We can either use our inequality, y is greater than or equal to 0, because your y values being used are bigger or equal to 0, or we can use our interval notation, which we start at 0, it gets a bracket because it's included, and it goes to positive infinity. Okay? Last but not least, a quadratic. That's the fourth one we're going to be dealing with in this chapter, in this section. F of x equals x squared. That squared is what makes it a quadratic. So if you see an x squared, it is a quadratic function. Quadratic function. Now, the graph looks like, and you've seen these before, it's a parabola. A parabola. That was dumb. Let's try this again. Alright. Here's my x. Nope. Doofus. Y and x. And it is a parabola. Looks kind of like this. Okay? Now, that's not perfect, but it's generally what it looks like. Goes through the origin, curves up to the right, and if we want to give it some points, we can. Like this is the point 1, 1. This would be 2. It would be at 4. All right, that sort of thing. That would be where the points are. The domain and range. Now, I know it's kind of going up like that, but it is going to the right forever. Same idea. Even though it's going up to the left, it's also going left forever. So again, left to right forever. That's all real numbers. Kind of seeing a pattern of the domain yet? The range, however, the lowest point is right there at 0. What is it going on? Stop! The lowest point is right here at 0, and it goes up forever. So, much like the absolute value, it is y is greater than or equal to 0. It is everything bigger and including 0. And if we wanted to write that as an interval, the lowest point is 0 and it's included. The highest point is infinity. And those are the 4 functions that we are going to be using throughout this section.